Space, the final frontier. Nobody's going to get that reference, بس مش مشكلة. What is space physics about? We talk about outer space, and we split it into primarily three basic concepts. which are إيه بقى? We want to talk about planet Earth and the details about the Earth and the Moon. We want to talk about the solar system and the sun, and how the solar system was formed, the different planets and their orbits and their details. And then we expand into the universe. So we want to talk about the formation of stars and what's the universe like, and the expansion of the universe, the Big Bang theory, and concepts that support the theory that the universe is expanding. Friendly reminder again, لو سمحتوا, you can use the checklist to go through and make sure you understand all the topics once you're done. Like, for example, you should know that the Earth rotates around an axis, which is tilted, etc. Go through these after you're done revising. If there's something you don't understand, let me know. نبدأ بقى الأول بplanet Earth. What is planet Earth? It is a planet. I know it's so basic, but we have to classify it as a planet. And it's the planet we live on, has an atmosphere, oceans, etc., etc. Planet Earth rotates around itself. So there are three types of rotation you have to keep in mind here. The first, هي إن planet Earth spins around itself, okay? And its axis, which it spins around, is tilted, مايل at an angle of about 23 degrees. مش لازم تحفظوا الرقم ده, you don't have to memorize that, but say, it's good to know. Because the Earth spins and it takes 24 hours to finish one full spin or one complete spin, we get days and nights. عشان the sunlight comes from just one side of the planet, ففي ناحية بتبقى منورة, it's daytime, and the other is nighttime. وطبعا because it spins, this alternates. And this makes the sun appear like it's moving across the sky. This is a very common question. أول كام إيه سؤال شفناه في space physics. Explain the apparent motion of the sun across the sky. It's because the Earth rotates about its axis once every 24 hours. The second type of rotation هي إن the planet itself بتorbit around مين? The sun, which is in the center of our solar system. خدوا بالكم ما بين الكلمتين اللي استخدمتها. I use the word rotate or spins around itself, and I use the word orbit when it goes around the sun, because an orbit needs a center that's not the object itself. But the Earth orbits the sun, and it takes 365 days to finish one orbit, which is 1 year. 365 is 1 year. Now, بسبب الأوربت وبسبب التلت, because of the tilt and the orbit, you get different seasons. For example, هنا, right now, the Earth's north is tilted closer to the sun than the south. يعني المسافة ما بين النورث pole and the sun is closer than the south pole and the sun. So the northern hemisphere, النص اللي فوق ده, gets more sunlight. that we get more sunlight, whereas this gets less sunlight. فبالتالي the northern hemisphere, where most of us are living right now, get summer. مش دلوقتي حامل, so we're heading towards summer, but let's say it's just hot. في نفس الوقت, people down in South Africa and South America and Australia, below the equator تحت هنا, they get winter because their temperature is lower. بس when the Earth orbits the sun وتروح الناحية التانية, and it goes to the other side, إيه اللي بيحصل? Now the northern hemisphere is farther away from the sun than the southern hemisphere. فالناحية السouth gets more sunlight. So now it's summer. And the north now gets less sunlight. So now it's winter. And طبعا the seasons in between, so from summer to winter, we call this autumn or fall. From winter to summer, اسمها spring. Okay? Now I said there are three rotations to keep in mind. One is the Earth around itself. Second is the Earth orbiting the sun. And third is the moon that orbits Earth. Earth is the center of the orbit. Okay. For now, the moon orbits the Earth in a circular path. But see, here's the thing بقى. We call a moon a satellite. So a moon is what we call a satellite, a natural satellite, something that orbits a planet. It takes 1 month to finish an orbit, and a month isn't really fixed with a certain amount of time. It changes a bit. A month could be from about 28 days and last up to 30 days. 31 hours, up to 30 days. But depending on where the moon is around the Earth, we see the moon differently. And I'm sure you've seen this. لو بصيتوا في السماء فوق, you realize at night, every night or every few days, you'll notice the moon looking a bit different. When the moon is right here, between the Earth and the sun, the sunlight that comes and hits the moon does not reflect towards us. So we don't see anything. We see the dark side of the moon. We call this a new moon. دي بداية الشهر. This is the beginning of the month. Okay? So this is a new moon. When the moon starts to move, and it's on the side of the Earth, you see half of the moon bright, because that's what hits, or that's where the sunlight hits and it reflects, and the other side is dark. So you see a half moon. We call this the first quarter عشان ده the quarter of the month. It's 1 week into the month. هذا ربع الشهر, quarter of the month. If you wait for another quarter, so half the month, another 7 days or 2 weeks in total, now you get the full moon, because ده معناها the sunlight hits the surface and we get the full reflection. So we see the entirety of the moon. So when the moon is on the other side of the Earth, عند نص الشهر, day 14, you get what? A full moon. دي ربع كمان, it's a quarter. If you wait for another quarter, another week, you get what we call the last quarter or the third quarter, which is half of the moon also lights up. بس هنا, if we see the right half light up, it's the left half that lights up instead. نشوف نص القمر بس only the left side is lit up. To us, that is. And finally, if you wait another week, another quarter, you go back to the start again, and it's the start of a new month. طيب. These all take 7 days, and until now, كل الquestions في past papers, if there are any questions from the past papers, الكلام ده, this was from the specimen or the practice sheet, only asked you for the main phases of the moon, which is what's the new moon? After 7 days, what's the first quarter? After 14 days, what's the full moon? Then the last quarter, and then a new moon again. Why is the last quarter darker? It's not darker, خدوا بالكم. It's because where the moon is relative to us. If I'm here, the moon is always on this side. This side is always dark, this side is always bright. تاني, one side is always dark, one side is always bright. Because imagine like it's a ball and the sun hits the back of it. The reverse, obviously. This side is dark, this side is bright. When the moon is to my left, yani, the moon is in front of me, I don't see anything because the light hits the back of my hand. When it's on this side, the front of it is bright. To me, that's the right side, and the left is dark. الناحية دي it's bright, and this side is dark. When the moon is behind me, إيه اللي بشوفه? This side is still dark, this side is bright. But because the bright side is facing me, I only see all the brightness. When it's on my right side, the moon comes here. Look at this. This side is bright. To me, this is the left. بالنسبة لي أنا, it's the left side. So in truth, it's the same side that's bright and the same side that's dark. It's just changing relative to me. أنا اللي عندي المون and smooth orbiting me. So it looks different to me because of where it is. Not because the light on the moon changes. Do you get the idea? Good. Excellent. فزي ما بقول لكم بقى the questions so far have been about the primary phases اللي هو the quarters the 4 quarters. بس it doesn't hurt ان احنا نعرف ايه اللي ما بين الكوارترز. Between any new moon and quarter, when it's still not bright, you get a crescent, which is a very iconic shape because we use it في الهلال بتاعنا في الايه والمسجد and to represent رمضان. كل سنة وانتم طيبين next week بقى ان شاء الله. So that's called a crescent. ده ما بين أي new moon و quarter. Then when the moon is mostly bright بس في حتة dark, when it's mostly bright but مش قوي, we call this a gibbous. So between a quarter and the full moon is a gibbous because a bit of it if it's dark and it's mostly bright. نفس الفكرة هنا بصوا. This side is mostly bright with a little bit of dark. هنا it's mostly dark with a little bit of bright. So it's called a crescent. لما بنتحرك from a new moon to a full moon اسمها waxing. Because, you know, it's like you're waxing it, making it shinier and shinier and shinier. ولما بتتحرك from a full moon back to a new moon, we call it waning. To wane معناها to lose. It's getting weaker. So it's getting less bright and less bright and less bright until it's dark. From a new moon to a quarter is called a crescent, a waxing crescent. And then from the quarter to the full اسمها waxing gibbous. والعكس صحيح. So waning gibbous, waning crescent. So far, no questions have asked about the gibbous and the crescent, but it doesn't hurt to know, just in case. Okay. Because unfortunately, the syllabus literally states that knows that it takes approximately 1 month for the moon to orbit the Earth, and use this to explain the periodic nature of the moon's cycle of phases. So nothing specific about which phase. Finally, the only calculation we have here is something called orbital speed, which is how fast the moon orbits the Earth, or anything orbits anything else. To find out the orbital speed, speed is distance over time. بس بما إن distance is the distance around the circle, the distance is actually 2 pi r, where r is called the orbital radius or the orbital distance. اللي هي distance from the center of the planet to the moon. So it's 2 pi r. And t is called the orbital period, which is the time taken to finish one orbit or one loop. Okay? This does not only apply to the moon. This applies to anything that orbits. So if we have a planet that orbits the sun, this works if it's a circle. Okay? If you have an asteroid that's orbiting the sun, that's also the same thing. So if we have a satellite that orbits Earth, and then a dish is like orbits Earth, that also works. It's the same thing. 2 pi r over t. Now, let's solve a few questions about this. The time taken for Mars. استنى Ahmed. I said if the orbit around the sun is a circle, صح? Notice how I said if, مش كده? Because Ahmed is asking, planets orbit the sun in a circle. I said if. عشان هنشوف بعد شوية, it's not always a circle. ماشي؟ The time taken for Mars to orbit the sun is 690 Earth days. The average orbital radius of the Mars is 2.28 10 to the power of 8. An Earth day is 24 hours. Calculate the average orbital speed of Mars in kilometers per second. خدت بالك هنا أحمد? He's asking you to get the time taken for Mars to orbit the sun. So what's he assuming? It's in a circle. That's why he's using the term average radius, because it's never perfectly a circle, okay? فيلا, we know the formula. V equals 2 pi r over t. So 2 pi, what's the radius? 2.28 times 10 to the power of 8 over, what's the orbital period? 690 days. But does he want it in days? He wants it in kilometers per second. The radius is in kilometers, سهلة. But I don't want it in days, I want it in seconds. Times 20, exactly, صحيح. Times 24, times 60, times 60. Times 24 to change it from days to hours, then hours to minutes, and minutes to seconds. هطلع بقى calculator. But 2 pi, lots of numbers, 10 power 8 over 690 times 24 times 60 times 60 equals 24. Very amusing, the number 24. It's 24.03, but 24 is fine. Kilometers per second. Okay, next. This is from paper 2, March. Which data is needed to calculate the average orbital speed of a satellite around the planet? So احنا عارفين الفورمula. 2 pi r over t. So do we need the distance from the satellite to the center of the planet? Yes. Do we need the radius of the planet? طالما جبنا distance to the center of the planet, I don't need the radius. Do we need the period of rotation of the planet? The time taken for the planet to spin around itself? Do I need the time for the satellite to orbit the planet once? Yes. So what's my answer? عايز دي ودي اللي صح. So which one is my answer? B. Okay. Next. Approximately how long does it take for the moon to make one complete orbit of the Earth? احنا قلنا 1 month. Nice and easy question. Next. From June 23 بقى. Paper 4. State the equation that defines the average orbital speed of a planet. State the meaning of any symbols you use. Now, if a question asks you to state an equation and state the meaning of symbols, I would rather not use symbols. And I would rather just write the formula in words because I'm going to have to explain those symbols anyway. فأقول orbital speed equals 2 pi. طبعا I can't like explain what pi is. He knows that. Times. Alhamdulillah. Times the orbital radius or orbital distance over, yeah, you can write pi, but I would rather you write the symbol itself, pi. So orbital radius over orbital period. That's how we define these quantities. ممكن تقولوا orbital distance, that also works. Suggest why countries that are a significant distance from the equator experience a significant temperature variation throughout the year. Now, this is a good question. It's very close to what seasons are. بيقول لي إيه? Why are countries that are a significant distance from the equator? بمعنى بصوا. Look at this. If something is here's the equator. If we have a country down here, إيه المشكلة؟ المشكلة إن right now the country at the very bottom, which is far away from the equator, or the very top also, is the farthest away, is super far away during winter, so it gets very cold, and it's very close during what? The summer. If you have a country down here, same country down here, during the winter it's very far away, and during the summer it's very close due to the tilting of the sun, of the earth, which means during the summer, when it's the closest, إيه اللي هيحصل? It's going to be very hot. And during the winter, when it's the farthest, it's going to be very cold. مش ده اللي قلناه؟ صح؟ Okay. So what are we writing back? I'm just letting people in. Okay. هنقول, because it's only one mark, we can say something like the sunlight. Why is it black? There we go. The sunlight during the summer months, or sunlight hours during the summer months, are longer than during the winter. So you get more sunlight during the summer than you get during the winter. Causing a significant temperature difference. If he had given me more marks, I would have explained more. Let's trust it. Next. Yeah. There's this relatively minor topic. Let's talk about the solar system now. So you have a ton of stuff to explain about our solar system. But the easy thing is what? Our solar system consists of the sun, which is designated as a star. You need to realize لو سمحتوا إن في فرق ما بين كلمة الobject نفسها, the description بتاع object and its name. So the object here is called a star. The name is the sun, okay? Just like we live on a planet that has a name called Earth or Mars or Jupiter, okay? So there's one star in our solar system. There's always one star in any system, in the solar system. It's in the center. And then we have 8 planets. You have to memorize them in order and by name. The 4 close ones are Mercury, Venus, Earth, we're always the third, Mars. The 4 big gassy ones اللي بعديها are Jupiter, Saturn, Uranus, and Neptune. So think of it this way عشان تحفظوها أسهل شوية. Mercury, you know, it's the closest one. And then Venus and Earth, احنا دايما number 3. Mars بعدينا, because that's where Elon Musk wants us to go. Then, when it comes to the big planets, these are the small rocky planets. The big planets, Jupiter, the one with one eye. Okay. Saturn, the one with the rings. Uranus, the butt of all space jokes. You know what I mean. And Neptune. Or Neptune, يعني لونه أزرق وبعيد. God of the ocean. Comes after Uranus للأسف. طب مستر فين Pluto بقى? There are other things other than the planets بقى. في حاجة اسمها minor planets, which includes Pluto. And حاجة اسمها asteroids, which are just small bits of rock that weren't joined to any other planet. And no other planet managed to get it into its system, essentially, into its body. We call these asteroids. And they orbit the sun in a circular path. It's usually between هنا وهنا, the 4 close ones and the 4 far ones, بس مش مهم. You've got moons. These orbit planets, just like Saturn. It has its rings and lots of moons. And you have other things like comets. A comet is a very small, very fast-moving, rock, essentially, that does not orbit in a circle. It takes a weird elliptical orbit. هنشوفها بعد شوية. Now, the important thing about the solar system, and this is super important, is that the 4 planets close to the sun are small and rocky. The 4 planets far away from the sun are large and gaseous. This is because of the way planets were formed in a solar system. Is it true that Neptune became a dwarf planet? لا. Pluto became a dwarf planet. خلاص. Pluto is categorized as a dwarf planet, not Neptune. Okay? Good. Honestly, we can't even consider Pluto to be a planet. The reason we call it a dwarf planet is because it orbits the sun, but it's bigger than asteroids. But here's the sad thing. Pluto is smaller than our moon. So it's hard to call it a planet when it's smaller than our moon كمان. You got the idea? That's why it's not called a planet. فسميناها a dwarf planet or a minor planet. Okay? Next. How was the solar system formed? 4 steps لو سمحتوا. Like how are planets formed? 4 steps. Step 1. You've got this big... Where's the diagram? I had a diagram here. Oh well, مش مشكلة. I'll draw it myself. First, you have a nebula. A nebula is just a ball, a big, giant ball of dust and gas, which means it has lots of different elements. This is important. It has lots of different elements. The ball is already like swirling and going around. But then you have gravity. in the center of that ball, which sucks in a lot of the mass, primarily hydrogen, okay? And that forms what we call a protostar, which the word proto in any space word essentially means it's in the process of becoming. So it's going to become a star. عشان we're going to see it later on لما نقول كلمة proto-planet. So it's in the process of becoming a planet. So the gravity, and this is inside بقى the star, gravity pulls the gas in, which causes a lot of friction and collisions between the hydrogen, and it undergoes nuclear fusion. Remember unit 5? Hydrogen fuses and becomes helium. So that's nuclear fusion. Now you have a star. A star is a stable star when the inner force of gravity, which keeps trying to pull the mass inwards, is equal to the outer force of the heat from the star. Because the sun becomes very hot, sun, which is the star, becomes very hot, it tries to expand. So that outer force of expansion and the inner force of gravity balance out. So it's now called a stable star. Here. So remember, big dust, cloud of dust and gas. Gravity in the center pulls matter together to form a protostar, and then it's a stable star. Type. The rest of the mass that wasn't pulled is busy swirling around, creating what we call an accretion disk. So basically, you have a star in the middle كده, and then you have all of the other matter just spinning in a very thin pizza dough-like disk. Just like if you get some pizza dough لما مسكتها and I spread it out, and you know those pizzaiolos that throw pizza in the air وبتلف كده, and it spreads out, it becomes super thin. ده اللي بيحصل. All of that other matter اللي ما تسحبش في النص is now spinning. While it's spinning, the gravity in different parts of the spinning disk starts to collect all that mass together. So it starts to slowly gather and suck up different parts of the dust and rocks and everything else. And this forms what we call proto-planets. So it's still forming planets. Now, ثانية واحدة. While this is happening, while this is spinning, you have gravity and you have the heat from the sun. But this is important. The heat from the sun causes most of the gases to expand outwards. We call this expanding gas solar wind. I don't know why it's doing this. So it's called solar wind. So solar wind is just the heat from the sun. And what does it do? It pushes away all of the light elements. So most of the elements that are gassy and light, think nitrogen, think of oxygen, think of helium, think of all of these light elements, they get pushed out. So the elements that are light are on the outside of the disk. The elements that are heavy are on the inside of the disk. And then the sun is in the middle. And then you form the planets. The planets that form inside the heavy area are small and rocky. The planets that form on the outer side of the disk are light and gassy. Okay? So if I, and it's a very common question, ask you, why are the 4 planets closer to the sun small and rocky? Or why are the 4 planets away from the sun, farthest from the sun, large and gaseous? هتقولوا ايه? During the formation of the planets or the solar system, the heat from the sun, you can call it solar winds, forced the lighter elements further away, pushes the lighter elements further away. So the closer planets were formed of heavier elements, and the farther planets were formed of gases. Do you get this, خلاص? There's a lot of rote memorization and description in Unit 6. Now, different planets have different gravitational field strengths. And if you remember, the gravitational field strength are defined as, or this is defined as the force per unit mass. G is equal to weight over mass, or force over mass, if you remember. And the value of G on Earth, on the surface of Earth, is 9.8 newtons per kilogram. That's what we talked about before in Unit 1. But the gravitational field strength of a planet or a star, depending on what you're talking about, depends on two things. On the surface, it depends on the mass, obviously. The greater the mass, the stronger the gravitational field strength in general. It'll apply more force. And second, the greater the distance from your planet, the weaker the field is. So if you move farther and further away from Earth, obviously gravity is going to get weaker and weaker and weaker. But if I tell you, for example, that Jupiter has a stronger gravitational field strength, that's because it has more mass. So more mass means more G. Less mass means less G. Okay? And since everything orbits the sun, who has the biggest G? Who's the big G here? Who's the strongest G in the entire solar system? The sun. Why? It's the heaviest. It's the thickest. It has the most mass. So the sun has the most mass in the solar system. So it has the strongest G, gravitational field strength. Okay? Now, Ahmed asked me earlier, Mr. Planets orbit the sun in a circle? Not always. Some of them are almost a circle. A lot of them are not. Here's the thing, most of these planets, minor planets, comets, they all have what we call an elliptical orbit. So it's not a circle, it's like a squished circle. It's kind of like an oval. The center of it is not in the middle. It's actually shifted. Something could orbit كده, where during some time, a planet could be closer to the sun than the other side. And not everything has the same ellipse. Some things are almost circular, just a little bit elliptical. And some things like comets are very elliptical to the point where they don't even follow the same path as, other planets. They're either super close to the sun and then they're really far away, and then they're super close to the sun and then they're really far away. But here's the thing, the distance from the sun affects your speed, affects the object's speed. The farther away a comet or a planet is from the sun, the slower it is. Why? Because it gains gravitational potential energy, so it loses kinetic energy. The greater the distance, the more potential energy you have. But as this comet starts to move closer and closer and closer and closer to the sun, its distance decreases and decreases and decreases. Well, potential energy decreases, and on the flip side, it speeds up. Kinetic energy increases. Obviously, if it's the closest it can be, and let's say the distance here is the same, this is the maximum speed it can have when it's the closest to the sun. لما تبقى أقرب نقطة من السن، أقرب حتة في السن من السن. Okay? طيب. Next. The last thing, doesn't the heat from the sun also add kinetic energy? No, it doesn't. The heat from the sun was only relevant during the formation of the system. But خلاص, once everything was formed, it doesn't matter anymore. Sure, the heat affects the temperature on the surface of a planet, but that's it. Okay. Now, sometimes a question will ask you to analyze certain types of planetary data, meaning I'll give you something, some kind of data about the planet, and tell me what it means, or what can we infer or deduce from that data. The first is something we've talked about before, distance, orbital distance, or in other words, orbital radius. The farther away you are from a planet, the weaker the force of gravity that acts on the planet, and the slower the planet moves. ده اللي قلناه هنا من شوية. Density. If I tell you that a planet has a low density, like Jupiter, for example, and Saturn, this means their size is very large, because remember, density is mass over volume. So the lower the density of a planet, the larger its volume, which means the 4 planets closest to the sun have a higher density than the 4 planets far away from the sun. Surface temperature. Now, what's that? Surface temperature simply means how hot or cold the surface is depending on the time of day. Is it day or night? Okay, so it changes. During the night it's cold, during the day it's hot. But there is something else that you need to keep in mind that the examiner could use. 2 things. Primarily, how close the planet is to the sun. That makes sense, because closer planets are obviously hotter, like Mercury, for example. And farther planets away are cooler. Makes sense, bardo. But 2 other things that are not as, let's just say common or apparent, would be the color of the surface. ممكن نرجع لunit 2 ونتكلم بقى عن black and white. So if I tell you that the color of the surface of the planet is different, that will affect how hot or cold it can be. Remember, white is a bad absorber and emitter. Black is a good absorber and emitter. طب, if a planet has or does not have an atmosphere, that also affects whether it can keep the heat inside the planet. So if you have an atmosphere, you will not cool down مثلا as quickly as a planet without atmosphere. يعني هقول لك حاجة, during the night, planet Earth cools down. Like if this side is nighttime, it cools down. But because we have an atmosphere, that traps some of the heat. Hence we have global warming برضه, خدوا بالكم. But Mercury, for example, does not have an atmosphere. But during the night, all the heat that it gains is almost all lost. Okay? بس خدوا بالكم, please do not mention atmosphere غير لو السؤال نفسه جاب سيرة الاتموسفير. So if the question mentions the atmosphere, that's when you mention it. Okay? Finally, gravitational field strength. What does that represent? This can tell you how much mass a planet has. The stronger the gravitational field strength, the more mass a planet has. Now, let's solve a couple of questions. Pluto is a dwarf planet. Figure 10.1 shows the direction of motion of Pluto as it follows an elliptical orbit around the sun. فهنا خلاص, he told you it's elliptical. مش هعمل أي حاجة, it's elliptical. Point X is the point in the orbit closest to the sun, and Y is the furthest. The orbital speed of Pluto varies as it orbits the sun. Describe how the speed of Pluto varies when it moves from X to Y and then back to X. So from X to Y, what will happen to the speed? The speed هتقل. It decreases. And then from Y to X, the speed will increase. وده كل اللي محتاجين نقوله. That's all. He didn't ask me to explain. He just said describe. So from X to Y, the speed decreases. And from Y to X, the speed increases. Okay? Next. Explain in terms of energy transfers why the speed of Pluto varies this way. قولوا لي بقى, why does the speed change this way? علشان as you move from, let's just say, choose one of them. As you move from X to Y, the gravitational potential energy increases and the kinetic energy decreases. طيب from Y to X العكس. So the planet or Pluto has the most potential energy at X and the lowest potential energy at, oh, sorry, the most potential energy at Y and the lowest potential energy at X, and vice versa. It has the most kinetic at X and the lowest kinetic at Y. فهنقول ايه بقى؟ As Pluto moves from X to Y, its gravitational potential energy increases, sorry, and is transferred to kinetic energy. Pluto has the most GPE at Y and the least kinetic energy at Y. It has the most kinetic energy and least potential energy at X. Do you also include gravitational field attraction to the sun? No, you don't. Why? Because the question explicitly asked you to explain in terms of energy transfer. Just mention the energy transfers. The average temperature on the surface of Pluto is 43 Kelvin. Convert this temperature to Celsius. صح. How do I convert that? Minus ولا plus from Kelvin to Celsius, minus 273. So 43 minus 273, which gives me negative 230 Celsius. Oh my God, it's freezing. Okay. Next. Pluto has a white surface. Allah, جاب سيرة الcolors. As Pluto rotates, the white surface alternately faces towards and away from the sun. يعني بيقول لك شوية look at the sun وشوية it's not looking at the sun. فشوية هتبقى سخنة وشوية هتبقى ساقعة. Explain how this affects the temperature of Pluto. Explain how this affects the temperature of Pluto as it rotates on its own axis. Let's talk about just the white. Let's just talk about the white compared to the black. Yeah. So let's talk about the white. White is a bad emitter and absorber, or you can say it's a good reflector of infrared waves, صح؟ فتفتكروا if it's a bad absorber and emitter, will it heat up slowly ولا quickly during the day? Slowly. And then لما تبقى during night time, it will cool down. Will it cool down slowly ولا quickly? برضو slowly. Whereas during the night, الناحية البلاك أو the dark side, it cool down very quickly. عشان كده temperature range بتاع Pluto white surface is smaller than the temperature range بتاعت black surface. يعني مثلا بلوتو هنا ممكن توصل من negative 100 لمثلا 200 degrees Celsius. Whereas in the dark side ممكن تبقى من negative 200 وتوصل لحد 400 degrees Celsius. Just like how the white side does not cool a lot, it also does not heat up a lot. The black side will cool down a lot and heat up a lot. Explain how this affects the temperature of Pluto as it rotates. فهنقول له in the white color is a bad absorber and emitter of infrared radiation. Okay? So it absorbs less heat during the day or when facing the sun, and it emits less heat during the night or away from the sun. That's the white surface is a poor or bad absorber and emitter of infrared radiation. So it will absorb less heat when facing the sun and emit less heat when away from the sun. طبعا we didn't mention temperature, so let's mention temperature. Absorb less heat when facing the sun. So it will have smaller temperature rise. Do I need to mention all of this? لا. I've actually written a bit extra, more than what I need. أنا كتبت أكتر بكتير. أنت محتاج إيه هنا؟ To mention core absorber and emitter of radiation that you have to. بعد كده one of these two things absorbs less heat, so it has a smaller temperature rise during the day, أو emits less heat, so it has a smaller temperature fall during the night. واحدة من الاثنين. Just mention one change. كل ده عشان هي درجتين بس. Okay? Next. Oh, this question. بص, this question ناخد break because this is like one of the heaviest and hardest questions اللي جت في past papers. يعني دي جت في variant 3 in June 2023 and it's a doozy. بص بقى. This is about orbits. It's a very innocent looking question about orbits. Figure 9.1 shows the sun as a central dot. And then the planets Saturn, Jupiter, and Earth. The planets orbit the sun anti-clockwise. From the Earth's orbit, the planets appear aligned. يعني right now, كلهم aligned. خدوا بالكم, a lot of the keywords here, like aligned, we're going to use later on. كمان شوية. Okay? Assume that Saturn takes 30 years to orbit. Jupiter takes 12 years to orbit. Obviously, Earth takes 1 year to orbit. On figure 9.1, mark the positions of Saturn and Jupiter 5 years after the original positions are shown. Label these S1 and J1 and show you're working. Let's do A. Right now, the duration is what? 5 years. Okay? 5 years. ثانية واحدة ثانية واحدة. 5 years معناها Earth هتلف 5 مرات. I don't care because Earth هترجع تاني مكانها after 5 years. But will Saturn go back to its original position after 5 years? وهي بتاخد 30 years to finish one loop? لا. طب how much will it move? شوية. How much will it move specifically? تعال نحسب. If one orbit, one full orbit is 30 years, then after 5 years, دي هتلف قد إيه؟ This is what you do. You take the time divided by the period عشان تعرف هي قد إيه. It's like a ratio of it. Oh, it's like 1/3, it's like 1/6 of the orbit. And the orbit is 360 degrees. To finish one circle, that's 360 degrees. This is for Saturn. فلو أنا قلت 5 divided by 30, that's 1/6 of the orbit, times 360. هيطلع لي 60 degrees. So with your protractor, measure roughly 60 degrees. This is 90, this is 60. And measure إيه? 60 degrees. ونكتب هنا S1. Because that's after 5 years. Makes sense. 5 years out of 30 years. طب Jupiter. Yes, it's not written to scale, but angles are always to scale. Distances are not to scale. Angles are always to scale. It doesn't matter if I draw a small circle with a dot in the center or a big circle with a dot in the center. خلاص? A circle is always how many degrees من جوه? 360 degrees. Now, أنا بقول لكم into 360 degrees ليه؟ Why do I want you to use 360 degrees؟ عشان انتوا ما تقعدوش تفكروا كتير where is it going to be. ما تقعدوش كده roughly تestimate يا ترى هتبقى فين. No no no. Get a good value. هتبقى صح. طب what about Jupiter؟ يا مستر Jupiter takes 12 years to orbit. 5 years يعني almost نصها. If you want, you could say mister it's almost نصها. It's almost half. فتقول لي Jupiter هنا. Which would be right by the way. لو عملتها كده بالحب. Like just like hop. Here we go. Guess work وتبقى صح. Or you take the 5 years. Divide it by 12 years. You multiply it by 360. فنقول 5 over 12 times 360. يطلع 150 degrees. Which is at the A. You put your protractor down. This is 180 by the way. But 150 is going to be somewhere here مثلا. فزي ما قلنا this is فعلا Jupiter 1. After 150 degrees. كده this way. Okay. Yeah. Next. The same question again. Figure 9.1. Mark the positions of Saturn and Jupiter 20 years after the original position. هنا ما قالش show your working because you now understand what the working is. He's not going to give you marks for the working anymore. Here you have to show it. 2 of the 3 marks are for the working. Okay? Or like 1 of the 3 marks, I'm sorry, is for the working. Label the positions S2 and J2. طب S2 هتبقى فين؟ هتقول لي مستر 20 years out of 30 years هتفinish قد ايه؟ It's not even one orbit يا نهاري. تخيلوا. Like I've lived my life up until now. I'm like over 30 now. And since I was born, Saturn didn't finish one orbit حتى. غلبانة Saturn دي. 240 degrees. Okay? Or like 2/3 of the orbit. فتقيسوا ل S2 240 degrees. So it'll be somewhere here. هو عايزها S2 أنا كنت هكتب 240. Okay. Then S1 type, J1 J2 قصدي. Okay, so it's 20 years out of 12 years. هو في حاجة اسمها كده؟ This means that Jupiter will finish one loop هتخلص لفة and then it moves a bit more. So it finishes one circle, one full orbit, and then it moves a little bit more. How much more? We don't know. بس هنقول times 360, which is 600. طبعا I don't know what 600 means. فهنقول minus 360. فيطلع لي 240 degrees. أو another approach, Rana, you're absolutely right, is to say إيه? I know إن في مستر 20 years معناها إن it already finished one oscillation شوية. فلو قلت 20 minus 12 over 12 يعني قلت 8 over 12 instead هتبقى صح برضو. Times 360 to a 240. I don't care if you subtract ال 12 من الأول or ال 360 من الآخر, it's still the same 240. جماعة 240 it's the same value as Saturn. It's going to be here, in front of Saturn هنا على نفس الانجل. Finally L أو مش finally بصراحة. I think there's another bit. Oh yeah, so this question isn't over. State what is observed from Earth's orbit after 20 years. قصده إيه after 20 years? Well, Saturn traveled 240 degrees كده. Jupiter traveled 600 degrees يعني it traveled 360. بصي يا زهراء, it traveled 360 once and then another 240 يعني لفت لفة وأكتر من نص شوية. That's what we did. Okay. What will you see from planet Earth? فاكرين أول كلمة قالها في question? From the Earth's orbit, the planets appear aligned في الأول. So what will they appear هنا? Aligned برضو. هنقول the planets will appear aligned. Okay, so they'll appear behind the other. بس that's all. So 600 degrees معناها ايه؟ 360 يا زهرة once. Okay, so we've got a little bit left, 240 left, and we mark the point. Choose two words from the list to describe each planet. Jupiter, large and gaseous. Earth, small and rocky. هنا بقى حتة analysis. Remember when we talked about analysis? كل دي بقى analysis. The average density of Jupiter is less than that of Earth. The gravitational field strength at the surface of Jupiter is greater than that at the surface of Earth. Explain how these differences in density and in gravitational field strength are consistent with your answer to CI. What CI؟ هو عايز ايه؟ طب واحدة واحدة. Density. Wait. هو بيقول the density of Jupiter is less than Earth. ايه علاقة دي بالlarge it's gassy صح؟ If it's less dense, then it has a larger volume and it's made of less dense elements. So it explains why it's gaseous, صح? It's made of lighter elements. We've explained the differences in density with my answers. So this is gaseous, this is rocky. So Jupiter is less dense because it's made up of lighter elements, whereas Earth is more dense because it's made of rocky elements. Okay, فحلو, that's one thing. Second, gravitational field strength. Okay, هو بيقول the gravitational field strength of Jupiter is greater than on Earth. Jupiter is large and Earth is small, which means Jupiter has more mass, whereas Earth has less mass. You can refer to size يا أحمد. You can refer to size. بس مش هنا. مش في ال gravitational field strength. You can refer to size بس مش في gravitational field strength. Instead, you can refer to it في ال قصدك ال density? Yeah, you can mention the size. It's fine. But I would rather talk about gaseous. Why? Because he said two words. خد بالك, this is me بقى analyzing the examiner, which is something I'll teach you when we solve papers بقى. I'm analyzing the examiner. He said, we are consistent with your answers to CI. فكلمة Jupiter is large والكلمة التانية gaseous. So clearly one of these things refers to large and one of them is referring to the gaseous. But clearly, if I'm using large and small for the field strength, عشان mention الماس, يبقى gaseous و rocky are for what? Are for density, صح? Okay? فهنقول ايه بقى؟ Jupiter has a lower density because it is mostly gas. خلاص? It is mostly gas. أو you can talk about Earth. Earth is mostly rocky. It has a higher density because it's mostly rock. طيب, or heavier elements, or more dense elements. Gravitational field strength. Jupiter has a greater field strength because it has more mass. It's larger and has more mass. Okay? 3 marks depend on what? 1 mark, okay, is for the difference between هنا فوق, lower density, and it has mostly gas. The 2 other marks are to say it's larger, دي واحدة, and the second is for it has more mass. So 2 points here. جبت سيرة large وخدت الحاجة اللي أنا بقى حافظها اللي هو greater field strength يا مستر. So if you remember back here, you said greater field strength means it has more mass. ف 2 marks down here and 1 mark up here. Larger, 1 mark, more mass, second mark. The average density of Jupiter is 1,300 kilograms per meter cubed. Its volume is 1.4 10 to the power of 15. What is the mass? يلا density. سؤال حلو كده عارفين after this very dense question يروح يديك dessert بقى حاجة كده خفيفة ويغير بيها الجو. The mass is density times volume and the mass is density is what? 1,300 times 1.4 times 10 power 15. يطلع 1.82 times 10 to the power of 18. طبعا dessert is nice and all بس طبعا لازم يحط حتة حبهان في الديزرت كده عارفين الناس الكئيبة دي. thank you. في ناس مركزة. thank you أحمد. thank you رنا. the volume is in what? kilometers cubed and this is in meter cubed and the question has 3 marks. oh crap ده في حاجة. what's the حاجة? you need to convert the kilometers to meters. how do I do that? From kilometer to meter بنعمل times 1000. So from kilometer cubed to meter cubed you multiply by 1000 cubed. تقعدش تفكروا كتير وتزودوا zeros. Just 1 times 1000 cubed وخلصوا بقى. So I'm just going to multiply this answer by 1000 cubed. So it's not power 18, it's actually power 27. Then it's in kilograms. Do you see how ridiculous this question is? Like, did you see how stupid this question is? How stupid long this is, come in? Anyway, that's like the biggest question about analyzing data and large and gassy and understanding orbits. حاجة كده جميلة. Yeah. Before we talk about stars, the rest is actually very short relatively, but it's very dense في الحتة دي. Okay. Before we talk about stars and the universe and finish the session, we'll take a short 10-minute break. Okay. So in 10 minutes, we return and I'll see you guys. Let's talk about the stars. And when I say stars, I mean specifically the sun. وإيه حاجة زي الsun بس في solar systems تانية. So first, you need to understand in the stars that we talked about, اللي بيبقى جواها طبعا gravity that pulls in the gas فبيحصل nuclear fusion and gases fuse together فبترelease heat and light. Our star, the sun, is a medium-sized star. It's not a large star, it's actually a medium size compared to other stars in the universe. Okay, it consists of hydrogen and helium. وبت emit light وheat, infrared ultraviolet. These are the primary things it emits. Okay, so we talk about thank you. Thank you. Now, so stars are powered by fusion, to be specific. هو مكتوب nuclear reactions, but I mean fusion, where if you remember in unit 5, we join or we fuse 2 hydrogen atoms to form helium and nitrogen and a neutron. بس مش مهم. The idea is that this releases energy. Okay? And as a reminder again, when is a star like the sun stable? 2 things. When the inner force of gravity and the outward force of the heat of the very high temperature fusion reaction of the sun are equal to each other. Okay? Now, the sun is the center of our solar system, which means stars are the centers of other solar systems. طب what's a galaxy? A galaxy is a bunch of stars, like a collection of different stars, which means technically a collection of different solar systems. ففي solar systems كتير جنب بعض كده وإيه؟ They're collected together. دي اسمها a galaxy. احنا we are in one galaxy because there are lots of other galaxies called the Milky Way. So our galaxy is called the Milky Way. احنا سميناها كده. And you have other stars inside the Milky Way برضه that are very far away, extremely far away. One of the points that the examiner likes to use for paper 2 for multiple choice هي إنه يقول لك the stars that make up the Milky Way are farther from the Earth than the sun is from the Earth. يعني المسافة between the Earth and sun, sorry, and the Earth is smaller than the distance between خلاص the sun and the next star. So between the sun and the next star دي بعيدة قوي أبعد بكتير من إيه المسافة دي. Anyway, next up بقى. How do we measure distances in outer space since the distance is very large? ما بنستخدمش meters وكيلومتers خلاص. Instead, we use a unit called the light year. What's it defined as? It's defined as the distance traveled by light in space in 1 year. 365 days. طيب بنجيبها ازاي؟ Like if I ask you, because I can and I will ask you in a bit, show me that a light year is 9.5 10 power 15 meters. You have to memorize this. So wait, Mr. Light year is the distance traveled by the speed of light in 1 year. If the speed of light is 3 times 10 power 8 and 1 year is 365 days, ولازم اغيرها من days لseconds. فهنعمل 365 times 60 so times 24 times 60 times 60. So from days to hours, hours to minutes, وminutes لseconds. هنقول 3 times 10 power 8 times 365 times 24 times 60 times 60. يطلع 9.46 times 10 power 15, which is 9.5 10 power 15. The speed of light times 1 year. بس نحولها from days to seconds. Finally, في حتة الستارز دي, you have to memorize the life cycle of a star. فالكلام ده كله just memorize it obviously, بس هتفهموها أحسن when you see it. So you understand what you're describing. Step 1 هنبدأ من حاجة قلناها من شوية. All stars in solar system start off as a nebula. What's a nebula? A cloud of spinning dust and gas consisting of different elements. The gravity attracts the matter and starts to form a protostar and then a stable star. بتفضل بقى الstar دي stable for a very long time. This is when it is nice and stable. خلاص هنا. And it lives for millions of years depending on the star. But then eventually الهيدروجين رياكشن اللي بتحصل دي, النيوكلير فيوجن اللي بتحصل دي, المفروض تتحول لهيليوم. Eventually you run out of hydrogen. خلاص بتخلص. After millions of years هتخلص. فلما تخلص there is no more fusion. يحصل ايه للستار؟ ثانية واحدة. حسب ايه؟ If the star is a medium star, and remember medium star زي مين؟ زي الsun بتاعتنا, so us. Once that is done, the star collapses and expands to form what we call a red giant. عشان تفهموا بالظبط ايه اللي بيحصل. لا, you don't have to mention masses. Not as values, just categories of medium and large, or medium and massive. So medium stars collapse الأول because خلاص they run out of fuel, فما فيش reaction, the gravity collapses it a bit and then restart the nuclear fusion reaction فبتكبر تاني. And it creates this giant sun-like thing called a red giant. This, by the way, eats up most of the solar system. يعني بتاكل most of the solar system. فالred giant دي بتعمل ايه بقى؟ بتburn شوية fuel كمان, like other elements, and then it eventually stops and cools down. So what is left behind? كل الماتر بقى that was broken down and fused من البلانيتس التانية بيتبقى. This is called a planetary nebula. And in the middle of the nebula, ودي بقى المهمة, the core of that sun القديم ده is called a white dwarf. Dwarf because it's small, white because it's glowing. مطرح heat from the sun. فبصوا, a star is formed from interstellar clouds of gas and dust called a nebula. A protostar in the interstellar cloud collapses, increasing in temperature due to gravity. A protostar becomes a stable star when احنا قلنا دي قبل كده. The inward force of gravity is balanced by the outward force due to the high temperature of the center of the star. And then it runs out of fuel. So this is the formation of the star. Just this is common for everything. هنا بقى حسب. Medium-sized stars become red giants. وبعدين red giants forms a nebula with a white dwarf at the center. You just learned the names, by the way. انتوا بس بتقولوا from A to A to A. This is why I prefer ان انتوا تبقوا بس باصين على الرسمة دي. You can memorize a diagram quicker than you can memorize a bunch of text. طيب ماشي يا مستر, دي خلصت خلاص. What if it's a massive star? And when I say massive, I mean huge, giant star. زي ألفا سنتوري بقى والحاجات التانية اللي عندنا. What happens with massive stars? A massive star collapses and expands to a red supergiant, which basically just expands and destroys most of the solar system اللي فيها. So it destroys most of the solar system. طب بعد ما destroy most of the solar system بيحصل ايه؟ بترun out of fuel تاني, بس خدوا بالكم بقى. Now it has managed to fuse very heavy elements. Iron, carbon, uranium, like حاجات تقيلة. بس as soon as it runs out of fuels, it explodes. مش زي الميديم بتاعنا اللي هو خلاص بترun out of fuel وبتقف بقى وبتريح وتكول داون وتسيب لي شوية planetary nebula ودور في النص. لا, it just blows up. This is what we call a supernova explosion. ها, عجبكم الcolors؟ عجبكم الألوان؟ supernova explosion, شفتوا؟ طيب, it explodes. لما بتexplode بتemit. لما بتexplode بتemit all of these heavy elements into outer space. دي بتروح تعمل نبيلز جديدة على فكرة. Like these just form different nebulas in different parts of space. إن شاء الله هيبقوا new solar systems بعد كده وستارز تانية جديدة, بس خلاص. The supernova explodes and throws out heavy elements into outer space. بيتبقى ايه من السوبرنوفا دي جوه؟ Remember, we still have the core of that old sun, our star. بيتبقى ايه؟ حسب الماس بتاعتها. If it was really 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 heavy بيبقى black hole, which there's no light from it. It's just darkness. Absorbs all light كمان من كتر ما الجرافيتي بتاعتها قوية قوي. And if it's a bit lighter, مش تقيلة قوي, تبقى neutron star. حاجة شبه الوايت دورف بس أكبر, and it's also glowing. Okay? طب فبص بنقول ايه بقى? A red supergiant explodes to a supernova. Okay? Forming nebulas. مش أي nebula بس واحدة. Multiple actually. Containing hydrogen and heavy elements. What is left behind بقى? Neutron stars or a black hole. مفيش condition, مش لازم أحفظ الcondition بتاعت when is it a neutron star and when is it a black hole. That's for advanced physics, right? بس واللي بيحصل بعد السوبرنوفا ايه؟ You can get new stars with new planets. قصة جديدة بقى. So again, تاني, how does a star start? We start with a planetary, we start with an interplanetary nebula, just nebula, dust and gas. Gravity forms a protostar, بيحصل nuclear fusion, temperature increases to a star. When a star runs out of hydrogen fuel, if it's a medium star, it expands and becomes a red giant, يعني بتكبر شوية to a red giant, and then it cools down and becomes a white dwarf. وبقت الماتر اللي ما كانش في السنتر بتاعت الستار بيبقى اسمه a planetary nebula. اتفقنا يا ياسين؟ طب what if it's a massive star? It expands and becomes a red supergiant, which blows up in a supernova, and that supernova leaves behind a black hole or a neutron star. That supernova بقى releases matter, heavy elements into space, which forms a new nebula with new hydrogen and new elements, كل حاجة. بس. Yeah. The radiation pressure is more than the gravitational force, so it expands. Again. The external هو ما بيقولش كلمة radiation pressure because that's not part of our terminology هنا. بصوا هو بيحب يقولها ازاي. Look at what he likes to say. Inward force of gravity ده اللي جوه. Outward force due to high temperature. فاللي بيحصل ايه؟ You need to understand what happens في ال red giant or red supergiant. Once it runs out of fuel, هو هنا بيقول it forms وخلاص. بس once it runs out of fuel, there's actually two actions that happen. There is less heat, so the gravity is stronger, which collapses the star شوية, which restarts in nuclear fusion. Like the gravity restarts the nuclear fusion, but it's with heavier elements. الهيليوم بيبدأ يفuse مش الهيدروجين, which creates a new, I can't call it a star because it doesn't last long, a new star which we call a red giant. That's why I call it a red giant. It's still a kind of like a star, but it's not as hot as a star because the fusion مش بيطلع energy كتير. So it just expands and it destroys the solar system اللي حواليها. And then it cools down وتبقى ايه؟ a white dwarf في النص وبواقي بقى النبيلة بتبقى اسمها planetary nebula. يبقى طب not a lot of questions here. ما بيسألش على دي كتير. So يلا. The energy generated in stable stars comes from nuclear reactions. This is from March 23. Which type of reaction occurs in the sun? We know it's nuclear fusion, صح? Helium nuclei break up? No. Helium nuclei join together? هما join together بس هو الهيليوم اللي بيجوين يبقى هيدروجين؟ ولا الهيدروجين اللي بيجوين يبقى هيليوم؟ D is the correct answer. Next. Fill in the gaps in the paragraph about the star much more massive than the sun. يبقى بنتكلم على أنهي branch؟ اللي تحت the heavy branch اللي هو red supergiant supernova neutron star black hole. The stage that follows the stable star in the life cycle of a star is بعد stable star في red supergiant stage. It then explodes as a supernova to form a dash, and this leaves behind a dash or a dash. So when it explodes, it forms a nebula, صح؟ بتعمل nebula جديدة, leaving behind either a black hole or a neutron star. So still kind of like a star, it's glowing. It's just not as bright as a regular star. So just memorize the order, obviously. This next question proves it. Oh, this is June 23, paper 21. This was from paper 4, by the way, اللي فاتت. Which stages in the life cycle of a star are listed in the correct order? يعني. Interstellar dust, صح. Stable star, صح. Protostar, لا. Protostar comes before the stable star, فنو. Protostar, then red giant, then stable star? لا, المفروض the stable star قبل red giant, so no. Red giant, then white dwarf, then protostar? يعني it was going so well. كان red giant وبعد كده white dwarf, صح. Protostar في الآخر لا. So obviously D, بس تعالى stable star, red giant, white dwarf? Yes. Did he skip a few steps في النص? Maybe. Or not. مش مهم. المهم إن order is correct. Last question here. Complete the sentences about the life cycle of stars. Protostars are formed from يلا. Protostars are formed from a فاكرين الترتيب؟ ايه اللي في الأول؟ النابلة بالظبط. يعني why did he leave all of this space? In case you wanted to say, يعني let's say you forgot the word nebula. So in case you wanted to say clouds of dust and gas, but from nebula. because it's a mark. A protostar becomes a stable star when دي بقى حلوة. ايه wait لا حلوة ايه مستر؟ He said when dash is balanced by dash. يعني يا ريتها دي هقول فيها الفول sentence. I'm going to mention force والforce التانية. So the let me write it here instead عشان I have a nice long line. The inward force of gravity is balanced by the outward force of the high temperature mass of the reaction. What's the difference between nebula and interstellar cloud? It's the same thing. Interstellar cloud of dust and gas is called a nebula. Nebula is the name, interstellar cloud of dust and gas is the description. كله. The initial fuel used to power nuclear reactions in stars is a what's the reaction called? Nuclear fusion. Or nuclear fusion. Next, stars that are approximately the initial fuel used to power nuclear reactions. Fuel. What's the fuel that's used? Oh, sorry. صح. You're absolutely right. What's the fuel? Hydrogen. My bad. Not the name of the reaction. The fuel is a hydrogen. Absolutely right. طب. Stars that are approximately the same size as the sun. فنرجع. Same size as the sun. يعني medium. Okay, هنا. Become red giant, which then form a dash with a white dwarf at the center. هنا بنسميها أي planetary nebula. في فرق بص بقى. A good question to ask يا أحمد إيه الفرق ما بين planetary nebula وان interstellar nebula؟ إيه الفرق؟ An interstellar nebula comes from a supernova. يعني when a supernova explodes, it forms a new nebula with new elements. This is called interstellar. Why? Because it's in a different part of the solar system. خلاص. It's not even the same solar system, it just goes away somewhere else. Whereas a planet, ودي بواقي this supernova explosion. Whereas a planetary nebula دي بواقي السولار system اللي اتدمرت when there was a red giant and then it cooled down, leaving behind the broken parts of the planet called a planetary nebula. Of the planets, sorry. ماشي؟ فplanetary nebula هنا في الميديوم والinterstellar nebula هنا the supernova explosion اللي بتترمي into other parts of space, not in the same part of space. Okay? Good. The final thing بقى is just a bunch of constants. And it's actually very important. We want to talk about the universe بقى. Remember, sun, solar system. Solar system is part of a galaxy. A galaxy بقى is part of billions of galaxies that form the universe. الجالكسي بتاعتنا شكلها roughly كده. It's like a spiral spinning thingy. Yeah. And that is called the Milky Way. The Milky Way has a diameter of 100,000 light years. You need to memorize this number. So it has a certain size. Okay. You don't have to memorize اللي أنا كاتبه هنا, like disks and the arms and the nucleus. Like it's just a certain shape and look of it. Like I'd like you to admire it because there's a certain beauty in the similarity ما بين solar systems وما بين galaxies كلها وما بين the structure of an atom وما بين cells that make up the human body. Like so many similarities في خلق ربنا. It's amazing. Now, redshift بقى. What is redshift? Let's define it. It is what? Now, قبل ما نكمل على redshift, الredshift والcosmic microwave background radiation والهubble constant all depend on a single model, which is the fact that the universe is expanding. تاني, the fact that the universe is expanding. يعني universe بيبدأ بحاجة صغيرة كده and then ده theory. We're not sure if it's true or not, but it's supported by different It's supported by different proofs زي ال redshift or behaviors observations زي ال redshift وال CMBR. We are assuming that the universe started at a single point and it's been expanding ever since the creation of all life and matter. ايه البروف بقى؟ Here's the first proof, number one, redshift. What is redshift? We live here. يعني بصوا, if you go back to this diagram, خليني أمسح بقى كل ده. If you look at this diagram over here, we live here where the sun is, the solar system دي. Okay? If you look at other galaxies, you look at stars from other galaxies, يعني this is our galaxy. If you look at the star from another galaxy somewhere else, ويجيلنا light منها. We realize that the wavelength of this light is more than the wavelength of the light on Earth. قصدي إيه؟ قصدي إن, for example, if I get blue light from galaxy X, if I'm getting blue light from the galaxy X, the blue light on Earth has a different wavelength. اللي جايالي من X is larger, which means في حاجة مسكت الwave and it stretched it out and made the wavelength larger. The only way that can happen هي إن السورس بتاعت الwave that's emitting the wave to me, يعني أنا واقف هنا بتفرج على الwave that's emitting the wave to me, بتstretch الwave. Why? Because it's moving away from me. So when stars and other planets, or sorry, stars and other galaxies move away from us, the wavelength of the light that comes from them increases. لو فاكرين بقى الspectrum of light من unit 3 لما رجعنا على unit 3, مش كان روي جيبيف؟ مين أطول wavelength فيهم؟ الريد. فسمينا إن الويف لينث بتطول أو بتزيد، سميناها red shift. It shifted towards the red. That doesn't necessarily mean إن بقى لونها أحمر per se. It simply means إن ال observed wavelength زاد. Why? Because stars are receding. كلمة receding means moving away from us. It's moving away from us. So when other stars and planets move away from us, their wavelength of the light increases, which is evidence إن إيه؟ إن distance ما بين الجالكسيز بتزيد. البيهيفير ده على فكرة له اسم بناخده في الاي اس فيزيكس، اسمه الدوبلر افكت، وبتشوفوه في الساوند على فكرة. you've heard it before. عارفين لما عربية إسعاف أو نقل أو حد ماشي بيضرب زمارة كده like somebody honking their horn, they go like beep. بس if they're rushing past you الصوت بيتغير، بيبقى beep، صح؟ بيعلى شوية when it gets closer and then it gets lower pitched لما بيبعد، صح؟ even though the honking is the same, the horn is the same. هو عشان بيتحرك the wave either gets compressed لما بتmove towards me or gets stretched when it moves away from me. Since the wavelength of light got stretched from distant galaxies, ده معناه the galaxies are moving away from us. ومش بس كده كمان, the faster they're moving away from us, the more it's redshifted. يعني لو لقينا الويفلنث بتاعت one galaxy أكتر من التانية, this means it's faster. It's moving farther and faster away. So that's what redshift is. Next, what is CMBR? Cosmic Microwave Background Radiation. CMBR is what? The microwave radiation of a very specific frequency observed at all points in space. Memorize this definition. كل النقط in space حوالينا فيها microwaves. If you measure that microwaves, it has a certain frequency. We call this cosmic because it's in outer space, microwaves because the microwaves, background radiation because it's always there. طب جت منين؟ اكتشفنا ان CMBR it was produced when? After the universe was formed. So CMBR was produced, and you can use the abbreviation by the way. ممكن تقولوا CMBR. CMBR is produced امتى? When the universe was formed. And since the universe was formed at a point, as it expands, the wavelength of this CMBR increases. يعني يبدأ الويف لينث بتاع الميكرويف ده يزيد until it's now a microwave. يعني هي الويف actually بدأت حاجة صغيرة gamma rays actually, and then eventually as the universe expanded the wavelength زاد بقت microwaves. So these are just two definitions you need to memorize. Finally, حاجة اسمها الهابل constant. What is this? It's a constant you also have to memorize. It is defined as the ratio of the speed at which the galaxy is moving away from the Earth to its distance from the Earth. Everything is relative to Earth. We're very selfish creatures على فكرة. Here we are on planet Earth. عندي galaxy تانية, let's call it galaxy X, moving away from us at a distance V and a distance D. The ratio of V over D is called the Hubble constant. The ratio بتاعت V over D, its velocity divided by distance, is Hubble constant. بما ان ال velocity is meters per second وال distance is meter, the unit is 1 over second. خلاص? The value of the Hubble constant is 2.2 times 10 power 18 per second. لازم تحفظوا الرقم ده للأسف. 2.2 times 10 power 18 per second. هتقول يا مستر أنا مش فاهم أصلا يعني إيه الهابل constant. What does it mean؟ هم حسبوها ليه؟ Well, لما أقول لك what is speed هتقول لي يا مستر it's distance over time يعني meters per second. يعني أنت مشيت distance قد إيه every second. لما أقول لك what is power هتقول لي يا مستر power is energy over time يعني joules per second. أمال هنا الهابل constant بيحسب إيه per second؟ The expansion of the universe per second as a ratio. It expands by 2.2 10 power 18 every second. This is a ratio. So it's about a percentage كده value. بتزيد كل شوية. This roughly calculates the expansion بتاعت الuniverse. تقولي ماشي يا مستر. اوكي اقتنعت. Hubble constant بيقول لي الuniverse بيexpand بريت قد ايه. والH هو اسمها HO بس هي H equals V over D. وبعدين استفدت ايه منها؟ ازاي جبنا ال V وازاي جبنا ال D؟ Well, the speed of a galaxy is found from ال redshift. فاكرين لما قلنا the faster it's moving away from us, the wavelength هيبقى redshifted أكتر. So the speed of a galaxy is from redshift. The distance away from that galaxy is obtained from the brightness of a supernova. إن كل ما الجالكسي تبقى بعيدة عني أكتر, let's say this is galaxy X, this is galaxy Y, this galaxy will be brighter in our telescopes. This will be a less bright عشان هي أبعد. So I can calculate the distance using brightness. مش هناخد أي formulas السنة دي. ال distance والspeed والdoppler effect ملناش دعوة. We're just stating best points. تقول لي ماشي يا مستر. انت جبت السبيد, you got the speed with the redshift, you got the distance with the brightness of the supernova, حسبت لي ال H0 which is the rate of expansion. The rate of expansion can allow us to calculate the rate of the expansion of the universe or the age of the universe. هيطلب مني ال question دي كتير, هنشوفها دلوقتي كمان شوية. We're going to see a question or two where he literally asks you to find the age of the universe. خلاص? He will ask you to find the age of the universe. بيسأل عليها, سأل عليها مرتين ثلاثة by now يعني. ال age of the universe هتبقى ايه؟ لو ال Hubble constant is V over D اللي هي per second, لو قلبناها قلنا 1 over H اللي هي V D over V هيطلع لي اليونت seconds. فجربوها. لو انتوا قلتوا 1 over H اللي هي 1 over 2.2 times 10 power negative 18 هيطلع لي الانسر 1 over 2.2 10 power negative 18 هيطلع لي الانسر 4.54 times 10 power 17 seconds. الرقم ده هو بصوا على اللي هقوله. time taken for what? For that galaxy called X to move away from Earth from the beginning of time. يعني احنا بنassume in the beginning of time Galaxy X دي كانت جنبنا. It was next to us. And then after 4.54 times 10 power 17 بعد التايم ده كله بقت هنا. ده اللي حسبناه. أنا كل اللي عملته تمام هكتبها تاني اهو. 1 over 2.2 10 power negative 18 هيطلع لي على الكالكليتر 4.54. like it's on your calculator 1 divided by الكلام ده. Okay. You have to memorize this constant though. H0. The value is always the same, yes. So for now, the value of the time taken for the galaxy to move away from us is 4.5 times 4 times 10 power 17 seconds. Since this is the time taken عشان Galaxy X تبعد عننا, this is the age of the universe. Because we're assuming كل حاجة بدأت جنب بعض وبعدوا. So this is how long the universe has been alive, essentially. Okay. هل هو, here's a question, هل هو يدين ال H0? لا, we said you have to memorize H0. 2.2 times 10 power 8, negative 18. Sometimes he will give it to you, but most of the time you have to memorize it. Okay? Okay. The formulas, تاني يا رنا, the formulas are simply constants that scientists decided to calculate and measure. H0 is V over D. What's V? The speed of a receding galaxy. What is D? The distance between Earth and that galaxy. لما قسمناهم طلعنا إن it's moving away from us at this rate, 2.2 times 10 power negative 18. This is how fast it's moving away from us. Not in terms of speed, but as a percentage. It's like expanding away from us at 2.2 10 power negative 16% per second. حاجة صغيرة قوي, بس every second بتبعد عننا. So that's how fast the universe is expanding, or how it's moving away from us. Okay? طيب. How did we get V? عشان this is a common question. How did we get V? From the change in wavelength due to redshift. How did we get distance? From the brightness of that supernova in that galaxy. لما قسمناهم طلعنا ال H. If you reverse that formula, like literally مسكت الفورمولاز دي and you flip over them, both of them as a fraction, H over 1, ايه اللي هيحصل? What do you get? 1 over H equals D over V, which gives me time. Because what is, افتكري كده, speed is distance over time. What is time? Distance over speed. Distance over V يعني distance over speed, which is time. What time? The age of the universe. Will he give us V and D? لا, he won't. Or maybe he'll give you V and ask you to calculate D. H0 is something you have to memorize, يا عبد الرحمن. Okay? No. You're welcome. Let's finish this up. First things first. State the shape of orbits of planets. Oh, this is from the previous part. The shape of the orbit of planets is what? زي ما قلنا, elliptical. Okay. Next. This is from March 23. Light from a distant galaxy is redshifted. What is meant by redshift? What is meant by redshift? So what is redshift? It is the increase in wavelength of light emitted by a receding galaxy. لو انت نسيت كلمة receding, it's okay, it's fine. بدل ما تقول كلمة receding ممكن تقولي by a galaxy moving away from Earth. يعني galaxy بتبعد عننا. That's what you say. تمام؟ Next. State the quantity that redshift is used to calculate. هو احنا بنستخدم ايه to calculate redshift? Or لا, what do you use redshift, sorry, to calculate? The speed of the receding galaxy or the distant galaxy. لا, redshift isn't used to get change in wavelength. It's used to get ايه في الآخر. What's the function? عشان على فكرة هي دي المهمة. The speed is found from the change in wavelength, which is redshift. You need to understand, redshift is the change in wavelength, an increase in wavelength. So what do we use? Redshift, which is the change in wavelength, to calculate. جبنا the change in wavelength. What do you use to calculate? The speed of that galaxy. Okay? Because كلمة redshift يا أحمد is the change in wavelength أو increase in wavelength. Okay, next. شوية بقى حفظ أهو. Two quantities define the Hubble constant, the speed at which the galaxy is moving away from Earth and the distance from the Earth. What is the relationship between V and D? And what is the current estimate for H0? فعلا. Current estimate لازم نبقى حافظينها 2.2 times 10 power negative 18 فit's either A or B. And then what's the relationship between V and D? لا ثانية واحدة, I'll write it down. H0 is equal to V over D. This means that if I make V the subject, and why is a relationship? V proportional to H0 times D. يبقى V and D are what? Directly proportional. كل ما السبيد تزيد the distance هتزيد, which logically makes sense. صح. So A is the correct answer. طيب. Paper A4 for June 23. A galaxy is moving away from Earth at the speed of 33 kilometers per second. ادي V. The value of the Hubble constant is 2.2 times 10 power negative 18. This time he gave it to you. This time he gave you the Hubble constant. مديني H0. What is the distance from the galaxy? Why is it D? طب سهلة يا مستر. H0 equals V over D. يبقى therefore D is equal to V over H. What is V? يلا 33,000. مش هقع في الفخ تاني يا مستر. kilometers times 1,000 over 2.2 times 10 power negative 18. أنا كده مبسوط جدا ومفيش أي مشكلة خالص. It's not like I skipped a word or a sentence كده وأنا بقرأ السؤال وما خدتش بالي إن أنا فوتت كلمة. يا ترى أنا فوتت إيه؟ What did I skip? Give your answer in light years. هو عايز light years. This is in meters. احنا بنستخدم meters per second وكلام. Remember, 1 light year is 9.5 10 power 15 meters. فعشان نحول من meters ل light years we divide by 9.5 10 power 15. فعشان نجيب ال distance in light years هنقول 1.5 times 10 power 25 divided by 9.5 10 power 15. هنعمل answer divided by 9.5 10 power 15. هيطلع رقم طويل برضو في standard form 1.58 10 power 9. 58 times 10 power 9. Done. Last question بقى. Or last two questions بسرعة. Show that 1 light year is 9.5 10 power 15. We've done this before already. هنقول 1 light year is distance. Distance is speed times time. The speed of light, كلمة show يعني you have to tell him everything, is 3 times 10 power 8. And the time is equal to 1 year. خلاص, which is كام? 365 times 24 times 60 times a 60. So the distance اللي هي light year is equal to 3 times 10 power 8 meters per second times 365 times 24 times 60 times 60. يطلع لي 9.46 times 10 to the power of 15 meters. State one measurement that is taken when determining the speed at which a galaxy is moving away from Earth. يا ترى, what do I measure? دي بقى ليك يا أحمد, because you asked me that question. What do I measure when I'm trying to find the speed at which a galaxy is moving away from Earth? What do we get? The red A, the red shift. You get the red A, shift. So بس يا اما تقول لي red shift يا اما تقول لي increase او change in ايه wavelength كده او كده. Write down an equation relating V and D. There I know the equation. H0 equals V over D. State how the distance of a far galaxy can be determined other than by using the equation. عشان محدش ناصح يقول له hey I can use D equals V over H. لا. هجيبها ازاي؟ Using the سؤال that's very direct. Using the brightness of a supernova in that galaxy. يعني نشوف البرايتنس بتاعت السوبرنوفا اللي في الجالاكسي ايه دي. Just brightness of a supernova. يلا بقى عشان this session has gone on too long. But this was another hard question. State what is represented in space physics by the symbol H0. هي ايه H0 دي؟ هي ايه H0 دي؟ What is H0؟ اسمها ايه؟ Like هو قال what is represented by. So what is H0 أصلا؟ The Hubble اسمها ايه؟ Hubble constant. مش bubble, okay? مش it's not bubble, it's Hubble constant. طيب. Write down the equation that defines H0 in terms of the speed and the distance. And when H0 equals V over D. The numerical value of H0 is 2.2 10 power negative 18. State the unit. نقول له it is per second أو ممكن نكتبها 1 over second. Use this value of H0 to determine an estimate for the age of the universe. هنقول له إيه؟ Look at how I'll write it. The age of the universe equals 1 over H0, which is equal to 1 over 2.2 times 10 power negative 18, which is equal to, I think we wrote down the value before, but I erased it. 2.2 10 power negative 18 هيطلع 4.55 times 10 to the power of 17. Next. دي عشان 3 significant figures, so I just rounded it up. State when cosmic microwave background radiation was formed and where do we detect it. يعني literally بيقول لي سمع لي two sentences بتوع cosmic microwave background radiation. فنقول له CMBR was formed during the formation of the universe. يعني من أول بداية الuniverse. Where do we detect it? We detect it in every point in space. بنشوفها فين؟ في كل حاجة ايه؟ in space. I forgot to post that. قلت لكم unit 6 كلها حفظ. Anyway, thank you very much. Unit 6 كده خلاص. And with that, we end here.